Hello, today we're going to continue our discussion of box and whisker plots, and we're going to start with descriptions of these graphs that do not have to do much with the numbers. So overall look of our data and how it represents in our graph. So we have three ways we can describe our box and whisker plot, not necessarily with use of the numbers. So we have skewed left, symmetric, and skewed right. So hopefully you guys seeing how symmetric type of graph is truly, I'm going to just kind of help with the explanation, is truly fits our understanding of symmetry from earlier grades. So symmetric shape is the shape that you can fold in half and both halves would be identical. So when we look at this box and whisker plot, we can see that whiskers are about the same length and the median, the middle of our data, is truly sitting in the middle. Skewed left and skewed right really have to do with these whiskers that are going to be longer on the left side or on the right side. So a little bit more variety of data will be happening here. So please listen to these descriptors as we analyze in our graphs today and see if you have any questions regarding that type of analysis. We're going to use this note for our examples. We're not going to go over every situation, really focus on these new terms today. So we're going to scroll down to question 2 right away. We're not going to build box and whisker, we're just going to focus on analysis. So in question number 2, we have box and whisker plot that represents prices in dollars of soccer balls at different sporting goods stores. So what we have, guys, is the 5-point summary. A quick reminder for you guys. So this is going to be your minimum data. This is going to be your maximum, median, lower quartile, and upper quartile. Or, I'm going to also write it below, Q1, that would be your Q2, and Q3. So there are all of the possible explanations or labels. Actually, let me go ahead and add one more. So minimum also is possibly to describe as lower extreme, and maximum could be also described as upper extreme. So variety of textbooks and applications could use their own approaches. You will see this data in high school. I want for you guys to be able to be comfortable with either of these terms. So let's take a look at our statements and questions for analysis. These are not answer choices. These are the steps that we're going to take for our analysis. So first one, find and interpret the range of the data. So the range of the data, guys, is the difference between maximum and minimum data. So we've already labeled them. So that would be 24.5 minus 8.5. So we have $16. $16 is the range of our prices in those different sporting goods stores. Our distribution of the data, it's not as extreme and obvious, but if you were to analyze the left side and the right side of the data, you guys will see that the right side is more skewed. So we would call this skewed right, because right side is the one that is stretched out. Okay. Point C, find and interpret the interquartile range of the data. A lot of times you guys will see this also the term interquartile range in a abbreviation, IQR, and that has to do with range between upper quartile and lower quartile. So range, just like earlier, is the difference in your data. So I am finding the difference between our numbers. So 20 and a quarter, and I'm subtracting 11 and a quarter, and that will give me IQR of $9. So middle 50% of the prices have the range, have the IQR of $9. And point D, are the data most spread out below QR or above QR? I mean Q1 or above Q3? This particular question again goes back to the skewness of our data. So on the left side, our whisker is smaller than the right side. So we have more variety, more spread on the right side. Data is more spread above Q3 or upper quartile. Right. I'm going to scroll down to example 3 and break down the analysis of two box and whisker plots. So as advanced math kids, you guys will see these questions a lot more frequently than just one box and whisker plot. It is very important to know how to analyze two graphs and compare and contrast them. So we have, again, a couple of different questions here to analyze. So question 1, or question A, identify the shape of each distribution. So for our state A, and if you guys need to do this to identify each of your quartiles a little bit more, a little bit larger, a little bit more obvious, you will see that state A is symmetric, and then state B, again, that's stretched out. On the right, we would call this skewed. This data is skewed right. Point B, which state's number of tornadoes is more spread out? When we talk about the overall spread of the data, once again, it has to do with the range. We mentioned this in the early example, and this is the difference between maximum and minimum. So for state A, 14 minus 0, the range is 14. For state B, and if you need guys to label these numbers on your graph, you definitely can do that to help your data analysis. And the range for state B is 23 tornadoes. So definitely a greater variety of days and occurrences. And the last statement, which state has the single least number of tornadoes in a month during the year? So your least number, hopefully you guys understand, this is your minimum. So state B has a minimum of 4 tornadoes, but state A actually has an incident of just no tornadoes. So we would say that state A has data of 0 tornadoes. Sorry, you did not see my note. So state A has data of 0 tornadoes in a month. All right. You guys could be asked a variety of examples. You could be asked to compare which range is bigger and smaller, just like statement B. You could be asked about comparing of the maximum of the data, of the median of the data, and so on. So let's analyze one more set of these box and whisker plots. And we're going to use example on the flip side of this particular note. We're not creating any more box and whiskers like we did yesterday, just focusing on the analysis. In this particular set of questions, we have some blanks that we're going to fill in. And for our analysis, we have two test data. So test 1 and test 2. We obviously seen variety of grades. And so let's take a look at our statements and see if we can fill in these blanks. The blank is the same for both tests. All right. For the analysis, once again, you guys are talking about 5-point summary. That's going to be important to keep in mind at all times. We do not have the list of grades. We only can use the data in our graph. So how do we know what is the same for both tests? Well, when one of these points are identical for both tests. So the maximum, hopefully you guys have seen, the maximum grade of 91 is the same for both tests. Okay? We do not have the same identical value anymore. We do not have it. Okay? All right, next situation, the median of the second test. So this is my median. So if I have the word than, it's greater than or lesser than. So when I'm looking at test 2, median is 84. Test 1 has median of 78. So median of second test is greater than median for the first test. Okay. Next statement. So now we have some kind of data for the first test is the same as some kind of data for the second test. So what I'm going to do, guys, I'm just going to show you how in the world do we know what data is that. Just like what we did right here earlier when we are drawing the line and trying to make the connection. So maximum was the same, and yep, this value right here, guys, that's what they're referring to. So in our situation, we call this as upper quartile. Upper quartile for the first test is the same as median for the second test. All right, next statement. The scores for test 1 or test 2 are more spread out than the scores for test 1 or test 2. A lot of times, guys, the actual length of your graph will help you kind of analyze that spread. So yes, longer graphs do represent a wider spread because they sit on the same number line. So you definitely can see that the test 1 definitely had greater variety of grades. They had some grades in 60s, whereas test 2 did not have any grades in 60s. So we'd say the scores for test 1 are more spread out than test 2. And we're almost there. So now they're comparing the range. Both range 91 minus 62, which is 29 points, and IQR of 10 points for the first test are, well, let's see, that would be 20 points and this would be 8. So greater than those values of the second test. So more variety of data created a wider range of data. And just as a quick reminder, IQR is difference between upper quartile and lower quartile.